Imagine a star explodes in a spectacular supernova, a cosmic finale so powerful it could outshine an entire galaxy. You'd think that's the end of the story, right? But what if the star comes back to life? Welcome to one of the universe's creepiest and most fascinating mysteries, zombie stars. In the vastness of space, stars live out dramatic lives. Born in clouds of gas and dust, they burn for millions, even billions of years. And when they die, they usually go out with a bang, a supernova. One type of supernova, called a Type Ia, happens in binary systems, where two stars orbit one another. One of these stars is often a white dwarf, the incredibly dense core left behind after a small star burns out. White dwarfs are like the corpses of dead stars. Sometimes these white dwarfs steal material from their companion star. As they feed, pressure builds. When they hit a critical limit, called the Chandrasekhar limit, they explode in a fiery supernova. Usually that's the end. They go boom and are obliterated, but that's not always what happens. Astronomers have discovered a strange variation of this event, the Type Iax supernova. It's like a failed explosion. It's weaker than a typical supernova, slower, dimmer, less destructive. And here's the creepy part. The white dwarf doesn't completely die. Part of it survives. Somehow it clings to existence, scarred by the explosion, but still there, still glowing. A zombie star. It's not just theory. In 2014, scientists found direct evidence of a surviving star after a supernova, SN 2012Z, in the galaxy NGC 1039, about 110 million light-years away. They actually had before and after photos from the Hubble Space Telescope. And after the explosion, they saw that the star hadn't vanished. It was still there, wounded, but alive. So how do zombie stars happen? Here's what astronomers think. When a white dwarf explodes in a Type Iax supernova, the explosion is incomplete. It's like the star coughed instead of sneezed. It ejects some material but doesn't disintegrate entirely. Something in the internal chemistry, maybe the way elements like carbon and oxygen burn, causes a partial detonation. Imagine lighting a stick of dynamite, but it only half explodes. The firework goes off, but the stick doesn't shatter. That's what happens to the star. It's damaged. Its surface gets blown off, but the core remains intact, drifting through space like a half-dead ghost. And sometimes it keeps feeding, still hungry, still alive. That's cosmic horror. Zombie stars are ultra-rare. Out of the hundreds of supernovae detected, only about 30 have been confirmed as Type Iax, and even fewer have surviving remnants. We're talking about events that happen maybe once every century per galaxy. And since galaxies are really far away, spotting them takes crazy timing and powerful telescopes. These stars defy everything we thought we knew about stellar death. It's like nature has an asterisk next to the word supernova. Oh, by the way, sometimes the star just walks it off. What zombie stars remind us is this: space doesn't follow simple rules. The universe isn't clean and orderly. It's weird, messy, chaotic, and full of surprises. We once thought a star dies and that's the end. But in this corner of the universe, death is not so final. Zombie stars hint at a reality where even destruction isn't total. Where a star can be shattered by an explosion so powerful it can outshine galaxies, yet still survive. And these undead stars are floating out there, right now, burning faintly, watching. The universe is full of strange things. Planets made of diamond, giant voids with no galaxies, stars flung out of galaxies like cosmic pinballs. And now, stars that refuse to die. So the next time you look up at the night sky, remember, not everything out there plays by the rules. Some stars burn long after they were supposed to be gone. Some stars come back from the dead.